Hey guys, welcome back to the shop, and we're back on our American Pacemaker project once again, trying to get this guy set up and ready to use for flood coolant, and also using our tool post here to drive our big spade drill and things like that. So the next thing that we need to do, and it's the last step we need to take in order to be able to put our spade drill in here and start our work, is we need to pin the tool post in place there. So that's one of the features of the multi-fix here. We have the Pee Wee Tools D1 size tool post, and the way this is made, and I'll show it to you, is there's actually 3 holes in the tool post body itself, the post, that's drilled to accept a 12 millimeter pin. I've got a 12 millimeter pin right here. I actually machined this one myself this morning because I thought it was 14 millimeter, and the holes on the top are 14 millimeter, but on the bottom side, about 1 inch from the very base, it's drilled 12 millimeter for that pin there. So I took some 1144 stress proof and made up my own pin there, just so that I can get this done today and I don't have to make another order from somebody, because nobody in town is going to have a 12 millimeter pin. So we'll just use that guy. So anyway, what I would like to do is go ahead and get my post indicated nice and square to the axis of the ways here, your Z-axis. Want to get this nice and straight, because once this is pinned in place, I want this to be where I always keep my tool post and my compound. I like keeping mine set at 29.5 degrees, always ready, because that's how I like to do it in my threading, is using compound in feed. And so that's where I always keep my compound set. So I've already got it set at 29.5. We got to get this indicated. We're going to take this bar out of here. This is the one that we're using for our number 5 Morse taper sleeve. This will go in there. We're going to have our drill bit out here doing our drilling, but since this one's split, I want to use a solid tool holder. So we're going to use this guy right here. We'll drop that in there, and we're going to get it indicated nice and straight right here. And once we get it indicated, we're going to transfer punch the whole location. We're going to set up a mag drill, drill it and ream it for a 12 millimeter pin, and hopefully that's going to be it, and we'll be ready to roll at that point. So let's get started on it and try to get this guy finished up and ready for drilling. We'll go ahead and remove our bar holder. This is the one that we're going to use to drive our drill bit. But I want to show you, since you guys, you may not have seen this. We've showed this in the past when I machined this bolt and got this all rebuilt and put on here. But if we take the handle off and this top plate, there you can see, you may not be able to see, there's one back here, but you have 3 holes. And what we're going to do is transfer punch. I want to get this indicated. We're going to use this hole here because this one has the best fit on the 12 millimeter pin. And when we drill this, we're going to use a transfer punch like this guy right here. And we'll punch the location. It's actually going to come through this casting, this area of the compound. It's nice and thick. There's plenty of material right there. The reason why I want to do it there and not on the T-nut itself is that whenever you spin this around, you're actually interfering with the bolts that hold this T-nut down there. So we're just going to go straight into the casting right there, and I think that's going to be fine. So one of the other benefits of having this particular tool post pinned, this is a 40 position tool post. So every notch when you move it around is 9 degrees. My understanding of the holes is the way that they're drilled in that's actually like an indexing pin. So you can have, I believe it gives you a total of 120 positions. So if it's lined up with this pin here and you got this square and you want to go, say 4.5 degrees instead of the 9 degrees, you can actually pick this up, rotate it, drop it down onto the hole, and that's going to split the divisions here on the 40 position tool post. I don't know why you would need that many positions. I've never used a tool post configured like that. I've always just used it like you see it right here, where we got our boring bar here, or our turning tool here, or we turn it on an angle because we want to come in at an angle, do a chamfer or something like that. So having all those multi-positions is not something that I personally need, okay? It would be interesting to see someone set this up and have a need for 80 or 120 different positions that you can drop it in there, but we're not going to worry about that. All right, so what we want to do first is get it indicated. So we're going to use this nice new tool holder here. We've got a nice flat surface there to indicate on. So we're going to go ahead and drop this on here. We don't need the top plate on there. That's just the top plate is a reference on your positions. There's a pointer that's going to go on here and a spring that holds it in place. So once this is on here, it'll be a permanent thing because we're not having to take it off. And you can see 0 all the way around to 40. And that's just whenever you drop it in there, this will turn and it'll line up. So you can keep up with your positions on this if you want to, you know what I mean? So anyway, we'll go ahead and get this indicated, transfer punch it, take all this off, and then we'll drill it and ream it. Y'all ain't gonna believe me, but I just put the indicator up, ran it down one time, and it's pretty close, right where I had it there. It's within 5 thousandths of being off. I just find that funny. We always like it when we look out and do that. I didn't straighten it up with a square or anything. I just dropped it on there, snugged it up, and there it was. Some of that eyeball precision. So we need to go ahead and crack it loose, or loosen it anyway. I'm gonna do just like that there. Get me a soft blow hammer over here and get it ready. Now let's see what we got. We need to go that way just a touch. -1, -1. Well, that looks pretty good right where we got it. I'm gonna go ahead and tighten this down, see if it stays there. It moved just a little bit. Honestly, that's gonna be okay. My plan with having this pinned in place is that, you know, I've got our compound set where I want it, 29.5. This is like my home position. And if this is off just a little bit, we'll be able to loosen these 4 nuts on the compound and just bump this to get that perfectly square. We're within about 1 thousandths right there, so it's not a big deal at all. So I think we're ready to go ahead and transfer punch our hole location. I was tweaking on it just a bit more. I've got that within 1 thousandths of being square and parallel there. So that's a good spot. Next up, let's go ahead and transfer it. Use this transfer punch. Go ahead and take the clamshells off. Get these out of the way. Now we can remove our post. Forgot what a close fit I machined that to on those threads. Got a video, if you guys check back, I believe it was last year. We made that bolt right there. And then there's going to be I can see our punch mark right there. So there's a look at the base. They got those serrations machined in here. That's how Multifix always designed their tool post, to help kind of bite into the top of the compound there or wherever it's mounted. So we got a good position right there. I like to just put a little witness mark around punch marks like that so it's easier to see where you're having to work. And then take a nice sharp prick punch. This is my Starrett. And go ahead and punch it one more time. Just try to get it nice and square. Just like that. All right. And hopefully our mag drill will fit up here and have enough material to mag down so we can do our drilling. So we do have a 12mm chucking reamer. I may end up having to cut some of this shank off to fit, but drill it and ream it. Okay, we got our mag drill set up. I've got my center point in there. So we'll see if we can get lined up on that punch mark. Looks like it's lining up good. I think that's gonna work. Hopefully that's gonna give us enough material there. There's only a couple corners on the mag that's not holding, but these things are pretty strong, so hopefully that's going to do the job right there. So we got to find a drill bit. I think what we'll do is maybe go with an 11.5mm drill, and then we'll use our 12mm chucking reamer and then just ream it. We're going to start with a spotting drill there, and then we're going to go in with a little stubby drill down to our depth just to kind of get a pilot going. That's a 5/16. And then we've got an 11.5 mm drill bit that will go to drill it to size. And then of course we'll use our reamer at that point. I ran out of drilling depth. I've got to reset it here. Just got to loosen this guy and drop it down a little bit more is all. There we go. Okay, maybe we can get to our depth now. We got our 12mm chucking reamer in there. I wanted to point out, I don't like the way this spindle system works on this Evolution mag drill, because it just seems, you see how much movement you got right there. It doesn't seem very rigid inside the spindle. So whenever you turn this on, you're gonna see it running out a little bit, but as long as you're centered up on the hole, it'll all align with the hole that you've already drilled in there. It just looks bad when it first starts there. Not ideal, but I mean, what can I do about it? This is how it works. So let's go ahead and see if we can get it reamed now. All right, there's our 12mm pin. Definitely got a very close fit on that. I can feel it trying to go down in there, but I'm sure we've got a little hydraulic pressure. I'm thinking what I may do, I may go back to the lathe and go ahead and might need a little bit of polishing. I mean, I made it a couple tenths under. Come on. There we go. Okay. I need to polish that just a little bit because it's a little bit too tight. I don't want it to press fit in there. But what I was saying is I may go ahead and just drill a hole down the center of that just to relieve the air pressure once we try to knock it in there. But I'd like it to where it just lightly kind of taps down in there. I shouldn't need to have to ever remove it, so I'm not really concerned about that. But I might just go ahead and relieve it with a small hole down the middle of it anyway, and go ahead and polish maybe a couple more tenths off this end right there. So anyway, we got her drilled and reamed, and I think that's going to work out pretty good. Modify this pin, and we'll start setting the tool post back up. We got a 5/32 hole drilled down through the pin, and did just a little polishing on there, brought it down a couple more tenths. There we go. I think it's a good fit right there. We'll put a little bit of anti-seize on that, and it should be good to go. We got our pin installed with a little bit of anti-seize. Let's go ahead and check our fit and see if the bolt lines up. All right, there's our pin. we get this installed for the final time, we're actually going to have our pointer on there. All right, well, screw it in, so it's a good sign. It's just a really, really close fit on those threads. There we have it. Love it. Now we don't have to worry about that thing spinning anymore. It's going to be locked into place. This is good. All right, we'll go ahead and get all this put back together, and we'll get this bolted down to the final time. And we'll check our indication again and make sure that we're still running parallel. If it's moved just slightly, which it may have, all we got to do is just loosen up our compound, and we'll bump this around until we get our tool post perfectly aligned with the travel of the lathe. Unfortunately, I cannot find the pointer and the spring that goes on this right here. I don't know where it's at, because I mean, I keep all of my multi-fix stuff in this bottom drawer right here. All my other tool holders and spare parts and things. And I thought it was right here in this corner. See, I've got some extra bolts, even a couple of taps. We got a book on it, but I don't know where it's at. I've looked in every one of my drawers here and I can't find it. So I don't know what I've done with it, but it's around here somewhere. And once I find them, I'm sure I'll find them at some point. I'll see them in another drawer, and that's when I'll get that on there. So we're just going to have to roll with what we got. I was really hoping to finally complete this multi-fix, but we're just going to have to go with that. So we did move a little bit. That's what I thought was going to happen. That's okay. Not too bad there. 25, 30 thou or so. So we'll just go ahead and bump this around. Put just a little bit of tension on it. That's a -1/2. That's within a 1/2 thousandths of being square. I'm going to call it good enough and tighten it on down. Yeah, we're good there. Now that we've got our tool post pinned in place, we've got it indicated nice and parallel with the Z-axis there of the lathe. Next step we need to do when we're going to go and start drilling with this thing, we got to make sure that our drill is perfectly in the center, in line with the, the tailstock and the center of the chuck there. I've been kind of thinking of a couple of ways that I could do this. I want to try to make it as easy and simple as possible each time we go to drop that in there. And I think I've got a great way. So we're going to get this set up. I'm going to show you what I'm going to do to get our tool holder here aligned with the axis every time we go to drill the hole. So each time we go to drill the next workpiece, we'll get our workpiece indicated like we need to, and then we're going to put our bar holder back in here. All right, get it locked in tight. Now, I've got this really cool collet chuck from Pee Wee Tools. It's an ER40, and this is made, you can use it with either the D1 or the D2 size tool post. And what I'm going to do is put this guy in here. I've got a close fit in there. Okay, put that in there like that, and we can make sure that there's not a bunch of looseness in here by just kind of snugging one of these guys up to where it brings it kind of close like that. Okay, should be very little movement in that clearance there. Okay, this, I want it to work like the spindle of a mill. We're going to put a Blake coaxial indicator in here, and we're going to use a live center in our tailstock, and we're going to indicate the center, rotating the indicator just like you would in a milling machine. I think that's going to be a really simple and effective way to do that. And we can start with alignment with this center point right here. Go ahead and put that in the collet. And we can use this to rough it in, get it really, really close, and we'll pull this out. We'll put the coaxial indicator in there, and we'll indicate the center. So we'll take a live center like this guy right here. Nice ground, smooth surfaces. So we got something really good to indicate on. Go ahead and get that installed. And by the way, I've already checked this spindle in the past. Whenever I had got the lathe originally set up, I put an indicator, the same thing, I set it up on the chuck, and I indicated this spindle, and it's extremely close. This is within a couple of thousand. So I'm determining that this is already on center line, so this is what we're going to use to indicate our drill for the chuck side. But you can see right here, we can go ahead and get it really close with our center point. I'm just going to come around here and eyeball it, get it up kind of close. And I'm looking this way, and we'll come on over till it looks like it's about in line. All right, and then we'll be able to do the height there as well. So we'll be able to adjust the height up and down, use our adjustment screw, and of course in and out with our cross slide, getting it into the position. So now that that's close, let me just back this out, and we'll get the center out of here. And we'll put our coaxial indicator in there now. All right, so here's our indicator that we're going to use, the Blake coax indicator. I love using this. It is such a handy tool for doing alignments like this with a spindle. To get that snugged up. That should be good. Yep, just hand tight on that. And you see now, just like if it's in the milling machine, where you're rotating the spindle, we just need to put our stop rod on here so this part doesn't spin on us. And we just need something to catch it. We'll use the, how about this right here, the chuck wrench. Just something to stop it, like that. Yep, that'll work. Probably keep it pulled against that shoulder. I think so. Okay, all right. Now we'll use our angled feeler. Now we can go ahead and just run our, I'm gonna go ahead and lock this quill. We'll run our center up here. I think what we'll do, if you're on the angled part, and this is moving in and out, you're not going to get an accurate reading. So we'll use this part of the center right there, and that should all be ground nice and true. Just like that right there. Okay, let's see what it does. That's going to work beautifully, just like being in the milling machine. So let's go ahead and indicate it. I'm going to move my case so I don't knock it out of the way. Maybe that'll work there. I'll get you a close-up later showing the movement. So it looks like we're a little bit low, and we're low there too. So we need to go that way. I told you wrong. We need to come back this way. Let me, let's loosen the compound. I'm sorry, the tool post. I'm gonna come up just a little bit. We'll just have to do this and just keep making adjustments on it. I went the wrong way again. Okay, maybe we should go down. So you're gonna have to just make a little adjust. Once we get the height set, we shouldn't have to play with that. Oh, that's really close there. That's within about 1/1000. Did I go too far? Just making a fine adjustment with the cross slide. So up and down, not even 1/1000. Let me see if I can get a little bit closer. So I need to go down another touch. I don't know if I can get it that any closer. Let's see. Might take a minute to get this indicated, but once we do the height, that should be good to go. That is 1/2 everywhere you look at it right there. That's pretty good. I think we're going to call that good, but I'm just demonstrating what we're going to be doing here, guys. I wanted to show you this. I think that's going to work really well once we get it aligned right here. Even if we're then 1 or 2 thousandths, I think that's going to be close enough for our drilling in the center there. So this idea, I think it's working great. Just rotate it just like you would a mill spindle and indicate that center of that tailstock there. This is what I plan on doing when we go to do the drill. So once I get it in the center, I'm gonna have, I'm gonna set a 0 right here on this compound, probably put a dial indicator. We can put one of our, let me see. We got one of these guys right here. Oh, there goes the wipers. But you can put one of these guys. This is one of the mag back indicators from Edge. You can put it on here like this and set you a 0 once you get it there. And as long as this doesn't move, you'll have a 0 set there, have a 0 set here, have this set on 0, so that if it does move, if you accidentally bump it or something like that, you can bring it back to your 0 and continue on with your drilling. All right, guys, this is the workpiece that we've got to drill and bore. A little over 7 inches deep. So, we're going to be going approximately 8 inches deep in this workpiece here. A couple of things that I wanted to point out so everybody's aware of. This was rough machined in. It's not finished yet. It was just rough to get it close to size. I'm doing this part for another machine shop because they didn't have a capability putting this in their CNC machine and be able to drill it and bore it. So that's why we're doing it in the Pacemaker. I also can't do it in my flex either because I don't have enough Z. By the time you stood this workpiece up and put a drill in there to go the right depth, I don't have enough travel. So that's why we're on the Pacemaker doing this job, okay? So there's gonna be some material that is milled off of this workpiece. And if you see this line right here, this is the material that's all going to get milled off the block. The reason why they left that on there is because you can see if you had a shape like this, it's going to be very hard to hold that in a 4-jaw chuck or in a lathe to be able to do this operation. So all they did was they just roughed it down close to size. They left it about an 1/8 inch thick in both directions there. And all this is going to be cleaned up and it's going to be finished and it'll look like a great part once it's all finished. So this was left on there so I could chuck on it, and this is how we're going to be doing it. So there is an offset to it so you can see, it's going to want to drop to that side. I am going to work on some counterweights, probably just do that off camera because I got to find some blocks of steel that I can drill a hole in and bolt up here to try to counteract that, counterbalance it. That I'm going to do that later. I just want to go ahead and get moving on this one to see if our drilling is actually going to work. I'm really anxious to see if my plan is going to work and the machine is going to drill the holes. All right. So we'll get back to that later. We've already got it chucked up in here. I've got some brass shim stock underneath the pads. That is only so that you can move it around when you're indicating. If you're chucking directly on the steel, it'll move, but it starts trying to like dig in and then it's hard to get it to move where you want to, okay? First thing that we're gonna do is go ahead and just check it lengthways to see if it's straight. And we can just bump it if we need to. And then once we know that it's straight, we're gonna use this center here to indicate on. So this is where the hole is supposed to be. They put that in there specifically just so I would have a location in order to indicate on, in order to drill it and bore it, okay? So we're gonna bring our indicator up here. And all I'm gonna do without rotating it, because you can see if you rotate, you're gonna move the indicator. So just leave it right about there. All right, let's see if I can, there we go, use our fine adjust. And I'm gonna run it down and I'm gonna see if it's straight. Pretty straight. That was 4 thousandths just right there. And I don't have it super tight. You can come in here and just give it a bump. All right, let's check it again. But this is what I'll have to do each time I go in there with it. That's within 1 thousandths being straight, that way right there. So what we'll do is rotate it and do that again over here on this side. I'm gonna have to put it in gear to hold it. Bring our indicator up here. Let's try it one more time. Let me make sure y'all can see it. I think you can. I know it's hard to see the indicators. You've got the skylights that put a bad reflection on these dialed indicator faces. That is straight there. Straight. I'd say it's within 1 thousandths. Not a problem. And you got sort of a rough, you got tool marks on there too. So we've got that nice and straight. Now we'll go ahead and we're going to put a center between centers up into this center drill hole in order to indicate the 4 jaws to get this running true on that center point. And just because I don't want to move this because it's our first one, I want to test this, we're going to go right through the middle of that tool holder. So I've got this Morse taper extension with a dead center in that side, and you can see you have a center on that end there that was used for whenever this was ground, so it's a good reference. So we're just going to hang this through here, just put it through the bar holder, run the carriage on up closer like that. Now I'm going to bring the tailstock forward. I'm going to hang it on that center there, and let's pick it up and gently bring it in here. I don't want to stab it. Bring it right there to that center there, okay? I'm just going to barely tighten up one of the tailstock nuts there to keep it from trying to float back. And so we're going to indicate the center that's running between centers. I'll show you what I'm talking about. Let me go ahead and put it in neutral. Just put a dial indicator there. Dial in your 4-jaw chuck so that this is running true. Pretty simple. Just indicate a center between centers. All right, how far out are we? About 1/8 of an inch. So we're high on this side here. I'm going to start with the highs and make sure that everything is good and tight. Loosen the low. Loosen the low, tighten the high. It'll make it easier once I get some counterweights bolted onto the chuck. High. We're going to loosen this one on the side here a little bit. High, low, high, low. Loosen the low, tighten your high. Now we're within 10. Loosen this one just a touch. Tighten that one. So now we're within a couple of thousandths that dial indicator. So you want to make sure you just get all this really tight. And once you can't move it anymore, you might have to crack it loose. So we're getting close there though. Okay, I'm going to have to loosen that one just a little bit. Pretty good. That's within 1/2 thousandths. All right, now what I want to do is make sure all the jaws are equally tight. This is a big workpiece. It's a lot of stick out here, but it's safe, it'll work. I've done hundreds of jobs like this in our big Monarch and the other pacemaker I used to run. These chucks will hold. And they'll give you a workout, which is what this one's proven doing today. All right, that dial indicator is within 1/2 thousandths of movement there. So I say that we are running nice and true in the center, and we should be good to spin it right there. How about we go ahead and spin it up, see what it looks like running. I got it set at 126 RPM. Still got the center in there, but let's just go ahead and turn it on and see what it looks like. This may be the RPM that we ended up running when we're using our drill. I did get some recommended feeds and speeds from Allied. I'm going to start down on the low side, maybe down 106, possibly around 10 thousandths, maybe 12 thousandths inch per revolution feed rate. That was coming from Allied Machine and Engineering, their recommendations. Doesn't sound too bad. Once I get some counterweights on the chuck, it'll offset that a little bit and it'll run a little bit more smooth. But I'm ready to see if this guy is going to drill. I'm really got my fingers crossed. I am concerned that something could be damaged on the carriage or on the lathe, you know, pushing that drill in there. But I feel confident too that we have an old piece of American iron. These old machines were built very heavy duty, very rigid, and I feel like this carriage and this machine setup should be able to handle that drill. We're gonna find out. If for some reason it doesn't work, I mean, I'm hoping nothing tears up, but there is clutches in here, so if it gets beyond the pressure at which this clutch is adjusted to, it should just clutch out and not break anything. That's my hopes. But if for some reason this thing just doesn't want to react well to the drill with the carriage, we can always resort to hand feeding it with the tailstock here as well. I'm trying to just utilize the machine power feed and let it do all of the heavy lifting for me. We've got our Morse taper sleeve bumped onto the shank of the drill. Make sure our coolant holes are flat like that. I think I'm going to get me a ratchet and a socket to make sure I get some torque on these bolts here. Make sure that they're tight. Should hold, but let's be sure they're torqued good. I think we're ready to drill. Get just a little extra torque on these bolts here. All right, I think that's tight enough. All right, guys, I think we're ready to run this. We've got the machine set up. We're running 106 RPM, so that should be 90 feet per minute on the OD of our drill there. And we've got it set at 10 thousandths feed per revolution. All right, let me just go ahead and put a mark on our drill here. Just gonna go from the very edge of the drill, about 7.5. That should give us enough length there. I got to double check the blueprint, but it's just over 7 inches is what our depth is. And remember, everything past that hole, this all gets machined off. In fact, when it gets machined, the hole is going to go all the way through the part. It's only blind just because we got the material there to work with. Okay, I think we're ready to run this. I've got our RPM set at 106 RPM, so that should be right around 90 feet per minute on the OD of the drill. I've got our feed set at 8 thousandths per revolution. That's a little lower than what they recommended, but I'm real nervous about this. This is the first time doing this, especially with the carriage, so I was trying to be a little bit more conservative. If everything looks good, we'll continue to bump the feed up a little bit, because they said that you could probably go up to 12 thousandths per revolution, maybe even more than that, but that's probably depending on the rigidity of the machine setup. So let's go for it and see what happens, all right? Boy, that seems awfully aggressive. Awfully aggressive. I think I'd feel a little bit better if we backed off the feed a little bit and let me prove this before I just shove it in there at 10 thousandths per rev. All right, we'll try it again. I got it set at 5 thousandths per rev this time. That's just the wrenches down here. That is a lot of tool pressure, guys. A lot of tool pressure. I just backed off because I wanted to change the feed now that we're in there. So it was definitely a little chattery as it's trying to get centered up into the hole itself. So that was at 5. I'm going to go on up a little bit. Let's see. Let's try 8. Make sure I'm in the right one here. AD. Let's try it again. It just seems too aggressive when I go up in the feed rate there. I think the machine is handling it, but it seemed better with the 5,000. So I think I'm gonna back it off because it seems like it's just pushing a little bit too hard. I wanted to get a measurement here just to see where it's cutting at. 3 inches, 260 thou is what I measured right there. So that's good. All right, what I did was I've got it set at 6 thousandths this time. Let's see. I'm filling up my chip sump or my coolant sump down there, but that's okay. I can scoop them all out of that. Well, it's working. I don't know how well it's working, but it's working. We're definitely putting a load on the pacemaker. We're just about to the line. Got about a 1/4 inch. All right, guys, so we drilled our first hole using our new 3 1/4 spade drill, and we had success there. So next step from here, I need to get a boring bar set up and bore it to size. I believe it's 3.345 is what the actual bore is bored to. I've got a bearing that I got a mic, and they want like a 1 thou, they said 1 to 2 thou slit fit in there. They don't want them tight at all. So we actually got a pretty easy tolerance to hit on our bore. But I think for the sake of this video and what we've got, we're gonna end this one here, but I'm gonna bring you guys back for the rest of this job. I have a total 15 of those blocks that I gotta drill and bore. So all we gotta do is set it up, drill it, bore it to size, and that's it. That's all we're doing. But we'll go ahead and have a separate video of the complete job, probably a little time lapse thrown in there of some of the stuff that we're doing, showing some of the boring, and then of course the completion of everything. But we've got a successful flood coolant system set up on the Pacemaker now. We're gonna be able to use that for turn-in. Even if we're drilling with the tailstock, it's gonna be great for that. And hopefully the machine is gonna continue to cooperate with me for the rest of these blocks. We got 14 more to drill. And this one made me nervous, but it was very satisfying to see it actually come to fruition and happen, because I've been planning this job right here literally for months, and wanting to get the lathe fixed up with flood coolant, get a drill in here, and hoping that everything is going to fall into place, and I think it did. So I hope you guys enjoyed watching the video, and come on back for some more whenever we get this entire job completed, okay? See you then.